Hello, this is Don using QuickTime to record an App Inventor tutorial for random number generators. I am using QuickTime to record this. This is a free solution for the Mac, but since QuickTime only records the screen and the audio in two separate windows, I'm going to start audio recording first, as you hear my voice right now, and then click Start Recording at about 30 seconds on the dot to sync up the audio with the video. And here we go. And it should be recording the screen now. At 30 seconds, I clicked start recording so that the audio would be in sync with whatever I'm doing on screen. All you would have to do is to load both the audio file at the end of this video and the video file into a video editor and sync up the video starting at 30 seconds in for when I was speaking into the mic. So, like I said, this is an App Inventor tutorial for random number generators. And just to give you an example of what random generators are, we have this equation here. And what this equation simply means is that, any number n plus 1 is set equal to that value times a constant a plus a constant b, and then you're going to take that number and then you're going to divide this number m into that number computed within these parentheses, and then take the mod of that, which means that whatever the remainder is from dividing this number into this number, you're going to yield that mod. And pretty much this is what computer programmers do in the background, is that they come up with formulas or other algorithms to produce randomness, or what it might appear to be random to the viewer. What I just described was pseudo-randomness, which is essentially, like I said, randomness generated in the background of an application by the computer programmer to make it so appear that whatever aspect of their app that this part is incorporated into is in fact random. This is opposed to true randomness, which is actually any unpredictable event, such as when you shuffle a deck of cards and you pick a card off the top. There's no way to really accurately predict that. And so what we're going to be doing today is making a PRNG, or pseudo-random number generator, in App Inventor's language. But enough about that. I have a demo up and running for you guys. This right here is just simply a random demo. And if you're already used to the App Inventor interface, you'll know that we have two buttons here. And we have a random number label that doesn't do anything. But this label right here will be whatever integer that pressing this next button will generate. Because what this does is that this button will generate a number, a random integer between 1 and 100 every time it's clicked. And so it'll set this label to whatever number that this generates. And of course the reset button will simply reset this to 0. And so that's pretty simple, really. If we go into the background of this app, we'll see the coding. We have pretty much very simple event handlers going on here. Event handlers, of course, you can go into your, the next button right here, and then you pull out this right here. When next button is click block, that's an event handler. You just go into my blocks, wherever the button is, and you pull that out. And once you pull that out, you can set the random text of that label. We called it a random number. That random number label, you can set the text to that, which you can simply find here. Set text to a random integer. Now, these blocks that we'll be using are random integer and random seed set. These can be found in the math section. If you go to built-in and math, we have random integer and random seed here. You should just pull those out since we'll be using them. And you'll set the random integer block to the text underneath next button clicked, and set the bottom range for 1 and the top range to 100. And so whenever this button here is clicked, it'll actually yield some random integer between these two values. Programming the reset button is very similar. You just pull out the reset button clicked event handler, and then what you'll notice is that sometimes these PRNGs have have seeds. And now the seed is essentially the initial number that is put into whatever algorithm or formula the computer programmer has defined in their language. And if you know that initial seed, then you can predict the inputs and outputs for the rest of your app, or every time you run that algorithm in your app. Because you know that initial number, you can run it through the sequence, and given if A and B in our equation here are constant, you can continue to yield those input and outputs for your application. And that's why it's predictable. That's why it's pseudo-random. And so you go over here, and then what clicking the reset buttons do, it'll set this seed, the seed of random integers, and then it'll reset the text to 0, the label to 0. And what that does is every time you click the next button after you have clicked reset, it'll use this seed to begin with and start generating random numbers to the user, or it looks like random numbers, but in fact it's a set sequence of numbers. And so I'll just give you a look here. So this is the emulator, a very useful tool for testing your apps, and it's already loaded up. Now mind you, the screen initialize block here, which I'll get to later, is deactivated, and so there's no seed set. And so when I click the next button, it produces a number of 21, and then 56, and then 19, and then 72, and then whatever other numbers that come about from clicking the next button. There is no seed, so it'll be actually a random integer between 1 and 100. But I'm going to click reset, and I'm going to click next, and I see the number 58, and then 66, and then 17, and then 97, and so forth. And then I'll click reset again, and if I click next, I'll still see that same sequence of numbers, 58, 66, 17, and 97. And that's because each time I click the reset button, it'll set the seed of numbers. And so I won't have to worry about, well, I will yield the same random set of numbers from this seed. And that's truly, a good way to demonstrate pseudo-randomness. But before this tutorial gets too long, we're going on 7 minutes here, let me just activate this block right here. And this is an event handler used for when the screen initializes. And let me just, while I connect to the emulator again, while I describe this, essentially this screen initialize, what it does is that when the screen initializes, when the app first loads up, and that's why we have to reconnect to the device, it sets the same seed that is called when you reset the button. And so from the initial startup of the app, you will see that the seed is set, and you'll see that same sequence of numbers starting with 58 and then so on and so forth. And then that more or less sort of proves to you that you can predetermine this sort of random sequence of numbers, when in fact it really isn't random. What we would have to do is to get rid of these seeds, and then perhaps when we restart the app, it'll still produce a set of random numbers each time we start up the app. But since we're setting the seed, you should see as soon as this emulator boots up that you'll yield the same sequence of numbers just like when you clicked reset. And so I didn't click reset, mind you. Look, I'm just only going to click next, and you'll see 58, 66, 17, and 97. And you'll see the same type of apps here. Same sequence of numbers, excuse me, for this app. And so, I mean, that's all I have really for you now for randomness. Try this out in your apps, or use other aspects of randomness for whatever app you're creating, whether it's an app inventor or Java or, Python or whatever you're using. And let me know in the comments below, how do you set up randomness in your app. This has been an App Inventor tutorial by Don. Thank you.